Okay, as we've seen in our last example, the more compounds per year we have, the higher accumulated value that we're going to get. So what if our compounds happen continuously? Well, let's take a look at the equation. So what happens when the number of compounding periods n becomes very, very large? Well, our interest rate over a very large number is going to give us a smaller value. So the ratio of r over n gets very small, while the exponent n times t gets very large. And we've seen from our previous answers, our accumulated value gets larger and larger. So for interest compounded continuously, if our principal P is deposited at an interest rate R and compounded continuously for a period of t years, we now have an exponential equation using the variable e, which is the 2.7, so on and so forth. And it's also a button on your calculator. So Harry finds an investment that pays the same 7%, but it has continuous compounding. How does this compare to his previous options? Well, again, we have our principal of $3,000. We have our time frame, which is 4 years, and we have our interest rate, which is 7%. Well, let's use our continuous compounding equation to figure out what the end amount would be. And again, I would plug this into your calculator, make sure you're getting the same answer. You get $3,969.39. So you can see out of all the options, this one is best because we're continuously compounding. Our number of compounds is very, very large. So if you can get an account that has continuous compounding, this is your best option.